This video is the reverse engineering and building of the Frequency Central's FC power supply unit, designed by Rick Holt, and the PCB designed by Tom Wiltshire. You can purchase the PCB from Frequency Central's website or from eBay, and then go about purchasing the components for populating the PCB. What I've done is I've just gone ahead and purchased the components and designed a PCB myself based around the PCBs that I've purchased from Frequency Central. I decided to make this video because a friend of mine was asking me about whether or not I could do some instructional videos regarding modular synthesizers, because he doesn't have any idea where to start. And though I do more DIY modules than I do about how to operate them, I decided this is the first place to start in understanding modular synthesizers, and that is the power unit. So this is what I've decided to do, is just go through the steps of building a power module. So in building this power module from scratch, what I've done is I've basically taken the PCBs that I've purchased and built, and using a multimeter track the plus and minus 12 volt rails and the 0 volt rail connections to the components, and drew up a rough sketch of a schematic. And for this second build, what I did was I used KitKat to review what I wrote, and now I'm double checking all the connections, all the continuity between plus and minus, and making marks and checking off where the components need to be soldered. Now, some of the things that you see me doing, like knitting the legs of the components on the opposite side of the PCB that they are mounted onto, is something I try to do often with the circuits that I work with, and it's to utilize every part of the componentry that I'm working with. It also reduces the need for additional jumpers, which I've been able to reduce this power unit down to about 4 jumpers altogether, whereas the previous one had maybe 8. But anyway, and as you can see, the zigzagging pattern in the center of this PCB is made up of the legs of the capacitors there, and that's the 0 voltage rail. And on either side of that zigzag pattern is your plus and minus rails, also made from the legs of the capacitors. So it's a way of utilizing every aspect of the components. And here, as you can see, everything's knitted and it's ready for soldering. It would be misleading to think that all you need is this power supply module to get your power to your modules. What I've done in the past is I've purchased a wall wart that takes the AC 110 here in Japan, or whichever what voltage you get in your country, and step it down to 12 volts AC. So this power module takes the 12 volt AC and then splits it into two separate rails, plus and minus. And the other factor is that if you want to purchase a wall wart, it's going to cost you. So what I've figured out is how to use a step-down transformer to get my power into my module. So if you notice that as I do the continuity testing, sometimes the beeps don't sound, and they shouldn't always sound, but as is the nature of putting these videos together, often due to the kinds of devices I'm using to make these videos, I often run into problems where audio and video isn't synced properly, so I have to do some editing. But regardless, it's just there for the sake of showing you that after doing all your soldering, you should check your continuity, and also prior to soldering helps, but then again, the solder helps to make the contact. At the end of this video, I actually test this power unit a couple times. I run a test on the original one that I had built, which has red LEDs. This has green LEDs. And the first test I do on the new power supply, I actually blow a diode, and you get to see the smoke. So have fun. Wasn't that fun? In this, you see that it's now working. It's producing the -12 and the +12 and the +5. And after this, I install it into my modular rig.